Hi y'all, it's Audrey. So today we're going to do a case of L'Hopital's rule that starts with the indeterminate form infinity minus infinity. So we have the limit as x approaches infinity of the square root of 4x squared plus 3x, all minus 2x. Now in the case of infinity minus infinity, our goal is going to be to turn it into a different form. Usually we're turning it into 0 times infinity. But sometimes there might also be a way, using, for example, trig reciprocal identities or finding a common denominator, to turn it into 0 over 0 or infinity over infinity. In this particular case, we have a function minus another function. There are no trig functions involved. There are no fractions involved. Our goal is probably going to be to turn this thing into 0 times infinity. So we've seen that in order to do that, a lot of times we want to factor out a greatest common factor, or sometimes not even a greatest common factor, just to factor something out to get rid of one of those infinities. So let's start off by plugging in infinity. So the square root of infinity squared is just infinity minus 2 times positive infinity. That does indeed give me infinity minus infinity. Now this 2x right here, I can see that if I can factor an x out of it, I'll get rid of that minus infinity, instead having minus 2. So the goal here, what I want to do is factor out x. In order to do that, I need to think of what x means inside of a square root. So what I know is that the square root of x squared is equal to x as x goes to infinity. So I'm going to rewrite this a little bit as the limit as x approaches infinity, the square root of x squared times 4 plus 3 over x. In other words, I'm separating that x squared away so that I can have an x to factor out of this part as well. So this gives me the limit as x approaches infinity of x times the square root of 4 plus 3 over x minus 2x. And now I can see, hey, look, I have a factor of x in both parts. I can factor out that x. So this gives me the limit as x approaches infinity of x times the square root of 4 plus 3 over x minus 2. Okay, so now what happens when I plug in infinity? We've changed the form of this thing, which means it should no longer look like infinity minus infinity. When I plug in infinity to that x, I get infinity. Then I have the square root of 4 plus 3 over infinity minus 2. Well, it turns out 3 over infinity is going to 0. The square root of 4 is 2. So this is like infinity times 2 minus 2, which gives me an infinity times 0. Okay, so we've turned this into the 0 times infinity case. We know what to do from there. We want to take this and turn it into the 0 over 0 or infinity over infinity case. So the question is, which thing is simpler to bring to the denominator? X or root 4 plus 3 over x minus 2? You had to guess. You'd probably say x, and you would be right. So we're going to take that x now. Oops. We're going to take that x now and bring it to the bottom to have the limit as x approaches infinity of the square root of 4 plus 3 over x minus 2 over 1 over x. And we end up with here 2 minus 2 over 1 over infinity, which gives me 0 over 0, which means I can use L'Hopital's rule. So let's do it. We want the derivative of the top. So 1 over 2, 4 plus 3 over x to the negative 1 over 2. We need to remember our chain rule here. This gives me negative 3 over x squared, all divided by negative 1 over x squared. Now, remember, before we do anything else, we want to cancel out everything that we can cancel out. I see I have a negative 1 over x squared on the bottom and a negative 1 over x squared on top. What's left there is a positive 3. So then this becomes, this becomes 3 over 2. I'm taking those constants that I have left over right there, the 3 and the 1/2, I'm bringing them to the outside of my limit. The limit as x approaches infinity, there's no longer anything left in the denominator. So all I have here is 4 plus 3 over x to the negative 1/2. let's plug in that infinity again to get 3 over 2. 4 plus 3 over infinity to the negative 1 over 2. 3 over 2, that's like 4 plus 0. Oops. 4 plus 0 to the negative 1/2, which is like 3 over 2 times 1 over root 4, which gives me 3 over 4 as my final answer. Okay, so note that in this problem, we started with infinity minus infinity. We factored out a thing, in this case x, because that allowed us to clearly see that we would no longer have infinity minus infinity. We factored out x to turn it into infinity times 0. Then from there, we turned it into a 0 over 0 problem. That allowed a simple L'Hopital's rule, as long as we remembered our chain rule. That's all. Bye, guys.